So now let's talk about the integration of explicit algebraic and simple trigonometrical functions. So let's start out by talking about the integration of algebraic functions. So let's consider these functions over here. And the first one, we have y is equals to x cubed. So when we differentiate it, what do we have? We have 3x squared plus 3x squared. So now let's go to the second function in which we are told that y is equals to 3x cubed plus 5. When we differentiate this, we know that x cubed becomes 3x squared and our 5 becomes 0. So I've said that integration is just the reverse of differentiation. So let's try to integrate this function back. So when we integrate 3x squared, as we see here, 3x squared with respect to x, what do we get? We get x cubed plus a constant. And what was our original function? Just x cubed. Now for the second scenario, when we integrate 3x squared with respect to x, we also get x cubed plus a constant. Now this constant here in this specific example refers to the 5 that we have over here. But why do we have a constant? We shall see that in the next slide. So now to integrate an algebraic function, it is given by this general formula. So we are told that the integral of x raised to the power n is equals to x raised to the power n plus 1 over n plus 1 then plus c. C is the constant of integration. So what do I mean by that? So let's try, for instance, to integrate x raised to the power 2 with respect to x. So what does that become? That becomes what? X raised to the power, my n in this case is 2. So that becomes n raised to the power 2 plus 1 based on the formula n plus 1 over n plus 1, which is 2 plus 1. And that becomes what? X raised to the power 3 all over 3. So now let's try to look at another example and integrate x to the power of minus 1. So what does that become? It becomes x to the power of minus 1 plus 1 over minus 1 plus 1. And that gives me x raised to the power 0 over 0. Now if you recall our discussion on functions, we said when you have a numerator divided by 0, you get an undefined function. So this expression over here is totally undefined. So how do we deal with that? When n is equals to minus 1, as in this case, we say that the integral of x to the power of minus 1 is just given as ln x. This ln here means ln x plus c. And there's always a constant of integration. So here you have x cubed over 3 plus c. And when you have a case where x is equals to minus 1, you have ln x plus c. Any other case, any other situation, you make use of this expression over here, aside from when n is equals to minus 1. So why do we have a constant of integration? So now let's look at our previous example that we solved. We told that y is equals to x cubed plus 5. Now when we differentiate this function, what do we have? We have 3x squared and our 5 becomes 0. So let's try to integrate 3x squared. So to integrate 3x squared, what is the value of our n? The value of our n in this case is 2. So it becomes 3x raised to the power n plus 1, which is 2 plus 1 all over 2 plus 1. And that becomes 3x raised to the power 3 over 3. Then remember you have the constant plus c, which becomes what? X cubed plus c. So now why do we always add a constant of integration? So we add a constant because, as you can see, if we didn't have a constant, we would have just gotten x cubed, which based on our original function we had x cubed plus 5. So this 5 would have been eliminated. So the reason why we have this constant is because we assume that when we differentiating, all the terms that were just constant must have been eliminated due to the differentiation process. So when we are trying to incorporate it, when we are trying to integrate, we try to incorporate those constants back by having the value c. And if you are given some specific condition, we can always try to find the value of c and get our original function, as we will solve in the last example. So let's try to apply these formulas to integrate some simple functions. So we are taught to integrate the following with respect to x. So the first one, we are told to integrate just 5, and 5 is a constant. So 5 can also be written as what? 5x raised power 0, because you know that anything raised power 0 is 1. So it's same thing as 5 times 1. So the integral of 5x raised to power 0 with respect to x equals to 5x, and I can see that n in this case is not equal to minus 1. So we use the first expression. So we have 0 plus 1 over 0 plus 1. And what does that give me? That gives me what? 5x raised power 1 over 1, which is same thing as 5x. So when we integrate 35, we got 5x. So this applies. So when you, in general, when you integrate a constant, you get that constant multiplied by x. So in the same way, the integral of 7x, of 7 rather, will be equals to what? 7x. The integral of minus 2 with respect to x will be equals to what? Minus 2x, and so on and so forth. So let's look at this next example where I told to integrate 3x. So this is that integrating 3x, and I told to integrate with respect to x. So applying our formula says that when you want to integrate x to the power of n, you have x to the power of n plus 1 all over n plus 1. So what does this become? My x in this case is raised to the power of 1. So this becomes 3 times x raised to the power 1 plus 1 over 1 plus 1. And what does that become? 3x squared over 2. So to the next question, we're told to integrate 4x raised to the power 5 with respect to x. So what does that become? Pretty straightforward. So again, it's going to be equals to 4. Then my x, I increase the power by 1. So I have 5 plus 1, which becomes 6. And I divide by the new power, which is x plus 1, which is 5 plus 1, which is also what? 6. So I have 4x raised to the power 6 over 6. So now let's try to look at this last example, and we're told to integrate 1 over x with respect to x. Now 1 over x I can write as what? X to the power of minus 1. So as I've explained before, when we try to integrate it using the normal formula, what do we get? We get an undefined function. So based on what I've explained before, when you try to integrate x to the power of minus 1, you get what? Ln x. So you have what? Plus your constant of integration, which I've omitted there. So you have plus your constant over here also, plus your constant over here, and plus your constant. So always take note never to forget adding your constant of integration. So this is what it is. So let's look at some more concrete examples now. So the first example we'll be looking at, we're told to evaluate the integral of this function. So the first thing we want to do is we want to try to rewrite this function in the form of x to the power of n. So we want to make it power of x raised by n. So now, and what we have to do is just to apply our law of indices. So if we remember from our law of indices, if you have the square root of a number, say to the root of a, and you have the number x, it's the same thing as having what? X to the power of 1 over a, if you recall. So let's apply that here to deal with this cubic root. So we can also rewrite this by writing out that this is same thing as the integral of 1 over, we now have x squared raised to power, since we are dealing with the cubic root, 1 over 3 times dx. So what does this become? This becomes the integral of 1 over x. So now I can multiply these two powers together based on another law of indices. The law that states that when you have x raised to power a all raised to power of b, it's the same thing as having x raised to power a times b. So we can apply that here. So this becomes 2 times 1 over 3, which becomes 2 over 3 dx. So now based on another law, we know that when we have 1 over x raised to power a, it's the same thing as having what? X to the power of minus a. So we can apply that as well here. So this reduces to x to the power of what? Minus 2 over 3 times dx. So now I've already written this in the form of x to the power of n, so we can integrate it using our formula. So when we integrate x per n based on our formula, we know that that will be equal to what? X raised by n plus 1 over n plus 1, and our n in this case is minus 2 over 3. So this becomes x raised by what? Minus 2 over 3 plus 1 over minus 2 over 3 plus 1, then plus my constant of integration. And what would that give me? That becomes x to the power of 1 over 3 over 1 over 3 plus c. And when you simplify further, this becomes what? 3x raised by 1 over 3 plus my constant of integration c. Pretty straightforward, right? So let's move on to the next example. So here we are told to evaluate this expression over here. And as we did when we're talking about differentiation of algebraic sums, to integrate algebraic sums, all we have to do is just to integrate each of those functions individually and sum them up together. So what does it become? We start out by integrating the first function. We have 2x squared. So that becomes 2x raised by what? My power 2 plus 1 over 2 plus 1. Very soon I'm going to be skipping this long process, but I'm doing it for now so you can get familiar with it. Plus 3x, my power here is 1, so the new power becomes 1 plus 1 over 1 plus 1, then plus, told you that when you integrate a constant you just have 8x, and never forget to include your constant of integration, so plus my constant of integration. So that becomes 2 over 3x cubed plus 3 over 2x squared plus 8x plus c. So this is what you get when you integrate this function. Let's move on to the third example. And here we are told to integrate this product of these two functions with respect to x. So the first thing we want to do is we want to expand what we have here so we can easily integrate it. So we have 1 minus x and x plus 2. So when we expand, what do we get? X times x gives us x squared. X times 2 gives us plus 2x. Minus 1 times x gives us minus x. And minus 1 times 2 gives us minus 2. So this simplifies to become x squared plus x minus 2. So now I can integrate this now with respect to x. So I can find the integral of x squared plus x minus 2 with respect to x. So what do? I just integrate each of these steps individually. So the first one becomes what? X to the power of 2 plus 1. You have 3, then all over 3. Then plus, this becomes what? X squared all over 2. And this becomes minus 2x. Then I had my constant of integration. So this is what you get when you integrate this function. So now let's look at the last example under the integration of algebraic expressions. So here we are told that if dy over dx is this, we should find the original function. So we are given dy dx and we are told to find the original function. And as I've explained before, we had an original function which we differentiated to get this, but now they want us to find what that original function was. So we have to integrate it or reverse the differentiation that we did. So I can write this out by saying dy is equals to 5x squared plus 3x plus 1 times dx. Now I can integrate both sides. And when I integrate both sides, the integral of dy, the integral of differentiation of y will just give me y is equals to, then I can integrate this function. To integrate the first one, I have what? The first time I have 5x, and I have raised to power 2 plus 1, which gives me 3, over 2 plus 1, which gives me 3. Then plus, this becomes 3x, yes, raised power of 1. So 1 plus 1 gives me 2, then over 2. Then the integral of 1 just gives me 1x, which is just x. Then plus my constant of integration. So this is the original function. but this is not really the original function because we don't know the value of c. But now we are given a condition that can make us find the value of c. We are told that when x is equals to 1, y equals to 0. So we can substitute that into the original function and try to find the value of c. So we know that we are told that when x is equals to 1, y equals to 0. So if we substitute it here, we have 0 is equals to 5 times 1 cube over 3, then plus 3 times 1 squared over 2 plus 1 plus my constant c. So what does that give me? So this becomes 0 is equals to 5 over 3 plus 2 over 3 plus 1 plus c. And what does that give me? I have 0 is equals to what? When you sum this and this together, you get 25. So sorry, this is 3 over 2 rather. Mistake over here, 3 over 2. You get 25 over 6 plus c. So if I make this a formula, I get my c value to be what? Minus 25 over 6. So now that I've gotten the value of my c, I can substitute it to this function to get the exact original function. So now I can write out that what? I can write out that y is equals to 5x cubed over 3 plus 3x squared over 2 plus x, then my c is what? Minus 25 over 6. So to recap, what we did was we tried to integrate this expression first to get the function, but we had a constant of integration. So given a boundary condition, or a condition that when x is 1, y is 0, we substituted it to the function to find the value of c, which is going to be minus 25 over 6. Once we found the value of c, we substituted back into the function and we had this final expression which gives us the original function. So now let's talk about the integration of simple trigonometric functions. So before, I told you that the integration is the reverse of differentiation. So let's try to see how that plays out. If you remember, I told you that when you differentiate sine x, what do you get? You get what? Cos x. So if I'm finding the reverse, that means that when I integrate cos x, what am I to get? I'm going to get what? Sine x, because integration is the reverse of differentiation. So that is why the integral of cos x is sine x. Then you have plus your constant of integration as always. Now let's move into the next function. We have d over dx of cos x. Now I told you that when you differentiate cos x, what do you get? You get minus sine x. So what happens now when I integrate minus sine x? When I integrate minus sine x, I get what? Cos x. However, if I'm just interested in integrating sine x, I can multiply both sides by minus to eliminate the minus over here. I'm now left in this side. I'm now left with what? Minus cos x. So that is why we have that the integral of sine x is what? Minus cos x plus c. And finally, I told you that when you differentiate tan x, what do you get? You get sec squared x. So in the same approach, when you integrate sec squared x with respect to x, what do you expect to get? Since it's the reverse, you expect to get tan x plus my constant of integration, and that is what we have over here. So let's see some examples. Here we are told to integrate sine theta and cos theta with respect to theta. So now we are not using x, we are using theta now. So the first one, we are told to integrate sine theta with respect to theta. So tan theta d theta. And based on what I've explained, the integral of sine theta will be what? Minus cos theta plus what? Plus my constant of integration. So the second one, we are told to integrate cos theta with respect to theta. And when I do that, what do I get? The integral of cos theta, as I've explained, is what? Sin theta, then plus my constant of integration. So this pretty much sums up the general idea behind the integration of algebraic expressions and simple trigonometric functions. So I want you to go to your textbook and try to practice some more questions till you get an hang of it. So that will be all for now. In the next section, we are going to talk about the rules of integration.